All right. Okay. Good morning and good evening, everyone. So actually, now it's AM in Seattle. I drink coffee to kill me a week. So yeah. So my name is Yunhe Feng. I'm a postdoc at Information School at the University of Washington. So I'm very happy to be here. I mean, to attend the second bias workshop and give a presentation of our paper toward fairness-aware ranking by defining latent group using inferred features. So for this paper, I co-authored with Danny, Saelid, Kali, who are undergraduate students in computer science and information science at UW, and Ruoyuan who defends her PhD degree in computer science at Rutgers University, and our advisor, the director of Infra-Seeking Lab, Chirag Shah at the University of Washington. So in our research work, we mainly focus on the group level fairness of exposure in rankings. So we give our answer to two research questions. The first one is to how to infer the features to construct groups for fair ranking, and the second one is to how to strike the balance between the relevance and the fairness in ranking. Actually, our study are conducted in the context of the academic search. So why the fair ranking matters in academic search? Here's an example. We can classify different researchers into different groups, like like the researcher from a group of small institutions and from big companies. So the author in small institutions, they may have some, a very limited number of the media outlets or resources. So it means that they will have few opportunities to get their research exposure to the public. But their research work should also be treated equally to get its deserved exposure in the search system. However, it's challenging to achieve a fair ranking in academic search. First, how to define the author group is totally open and complex. And second, fair ranking algorithm must perform robustness across various applications. And the last one, we care about the trade-off between the relevance and the fairness. So we defined two types of group in our paper. The first one is the gender, and the other one is the country. We use the two type of the groups because they are the two demographic features general enough for different applications. And the re-ranking algorithm designed based on the group of gender and country are more likely to demonstrate strong robustness across scenarios. So if the feature is self-contained, which means that the features are stored in the dataset explicitly, we can simply extract the feature from dataset, and based on the extracted feature, we can build the group. So it is very easy. But in our study, we use the gender and the country information. They are not available in the Semantic Scholar Research Open Corps. So this dataset is released by AI2 and also used in TREC 2020 fair ranking track. So in this dataset contains features like the paper title, the abstract author name, number of the citations, but there's no information about gender or no country. So for the paper title and abstract, we use the two features to calculate the relevance score. So which means that, for example, we have a query, and for this query, we will calculate the similarity based on the information of paper title and abstract. So how to infer the gender and the country information? So here's the whole picture. We have this set, and we mainly rely on external resources, including the worldwide website, the external document, and the APIs. So in this way, we can infer the features, and based on infer feature, we will build our groups. First is to infer the gender. we mainly use the genderized IO API. This API is powered by a very large dataset that maps the first name to a binary genders. This API will return the male if there's more instance of the name associated with man. Otherwise, returns the female. So if the name can't be found in the this API's dataset, it will return a value of unidentified. To infer the country information, we use different methodology. So first, we will check the author's name in Google Scholar to see whether there exists a Google Scholar profile for the author. If there is no such a profile, so we will Google the author's name and use the keyword of homepage and to script the first URL and then pass the country code. So if the Google Scholar profile for the author is available, we will try step 1 to 5. Step by step. Like if the step 1 can't get if the step 1 is unsuccessful, we will try step 2. So we will pass the email extension to infer the country code, pass the affiliation of the university's name, and also for the city's name. And we also Google the author's name and author affiliation directly and script the first URL. And finally, we try to, and we use the Google Places API to infer the country. So here is the country inference result. The country feature has high dimensions. So we group them into two categories. One is the advanced economy, and the other one is the developing economy. So it is done based on the World Economic Outlook report. So here are the results we get. So after the group of gender and country are available, we strike the balance between the relevance and the fairness. So we design the cost function to do this. So here is the cost function. It mainly consists of two components. For the first one, the f function here, the f is the reverse normalized BM25 score. The BM25 is widely used search engine, it's a ranking function used in search engines. So here we use the reverse normalized score because we want to minimize this cost function. So here the 0 represents the highest relevance, but 1 represents the lowest relevance. So and for the second part is the unfairness. We use the KL divergent to calculate the unfairness regarding different definition of group. Like the G here means the gender, the C means the country. So for each of the components, the relevance, the group, we designed the weight. So the sum of the weight, the weight of relevance, the weight of gender, weight of country is 1. So here's the whole algorithm. We showed how we do the fairness aware ranking. So the input is the document corpus, and Q is the query of interest. The L is the expected ranked, the length of the expected ranked list, and the W is with vector. So output is the re-ranked list. So first we will initialize the re-ranked list as empty, and then we will retrieve relevant document candidate from the entire document corpus for the query queue. So which means that we will retrieve like top 200 document from the entire corpus, and next we will select the L document candidates. So inside this for loop, we will select the best document candidate that has a minimal cost function, and then we use the equation I just showed in the previous slide to calculate the cost function. And we added the document with the minimum cost function to the ranked list, and also at the same time we remove the selected document from the document candidate corpus. So finally, we will get a ranked list.
Yunhe, you have 1 to 2 minutes, okay?
So here is our result. So we show actually we have two baselines. The first one is BM25. BM25 don't consider the fairness. So we can see for the BM25 the point here and here they have highest they have very high utility, but the fairness is very low. So for the random ranking, uh, here it's very interesting that on the group of the country it has a higher unfairness, but on the group of the gender, the unfairness is very low, which means that random ranking is sensitive to the definition of group. So for our method, if we don't consider the BM25 score, like if we set the weight of relevance to 0, we can see the blue dots. So here, the utility will drop greatly. It's the same for the group of the gender. But if we set a positive value to the weight of the relevance, we can see our algorithm performed very robust, and the performance is comparable. So our research also have some limitations, like when inferring the gender, we just treat it as a binary attribute and guess through the first name. But the gender is far beyond the limitation of the male and female. I mean the category of sex. So and sometimes the first name tells little about the gender identity. So in the future, we will undertake fine-grained gender detection and use multimodal data to do this. And also, we will use more public personal location data to infer the countries of the author. So here's our conclusion. So we inferred the feature of gender and the country using external resources, and we also propose a weighted fairness-aware ranking algorithm.